Little prompt about recording. Oh.
It's recording. I can see in the corner.
All right, well, we'll get started. Good morning, everybody. Thanks so much for spending your Saturday morning with us. We're going to get started in just a minute here with our Help Solve Climate Change with Global Warming workshop. And we're so happy to have you here. This is part of a series of workshops that CRS has been coordinating over the last year, actually. We did a series in the fall, and then we're just finishing up with this one and another few for the spring. And that'll wrap up our work over with this series of workshops focused on building environmental and climate science literacy. So this workshop is actually in collaboration with StopWaste and the Chabot Space and Science Center, along with Community Resources for Science. So we're excited to present an interactive workshop with you, and we'd really love to hear your ideas about how these ideas might be integrated into your teaching and your work with students, or potentially even other teachers. So we're going to jump right in with our couple introductory slides to get us kind of warmed up and started. And so I want to start with this image here. This is an image of the Earth, full Earth, if you will. It was actually taken by the final mission on its way to the moon, the Apollo 17 mission in the early 1970s. And what happened, this was really interesting, was as the astronauts were flying to the moon for their final trip, they looked back out the portal and the full Earth was illuminated. They didn't anticipate this, but it gave them a unique opportunity to actually take a photograph out the back portal. And it was a catalyst for understanding the Earth as one big system, as one place, has all the life that we know at this point that exists in our known universe. Now, we may make some new discoveries. And right around the same time was the beginning of Earth Day. So Earth Day started in 1970. So it was a catalyst for this idea of thinking about the Earth as one system and something that is fragile and something that humans should think of themselves as stewards. So I really love this image. It's one of the most used images around the world today. So I thought that was a nice place for us to start our workshop this morning. So let's talk a little bit about our team, and then we'll also love to hear about you a little bit in just a minute. So our team, as I mentioned, consists of a collaboration among the CRS team. So myself, also our executive director is Teresa Barnett is here on the call today as well. And so each of our presenters is just going to give a brief introduction of themselves.
Good morning, everybody. My name is Angelina Vergara, and I'm the StopWaste Schools Program Manager in Alameda County. And we support students, teachers, families, school districts on making sure that we can take action to be more green and more sustainable and help fight global climate change by global warming. Good to see ya.
Good morning, everybody. My name is Christian Aguilar. I go by he, him, they, él. I'm also part of StopWaste, part of the schools team. My role primarily revolves around the free 4th grade field trip education centers at the local transfer station.
Great, and again, I'm Eric Havel. I work with the Community Resources for Science, focus on professional development workshops like the one we're running this morning with an emphasis on environmental education and climate science. I had a long career at the Chabot Space and Science Center as an employee as well, and have partnered with StopWaste on many projects over the years. So really, I think of this as our broader team today working together.
Hi, everybody. I'm Haley Bilchin. I work at Chabot Space and Science Center. I am a science educator, educating field trips that come through the center, and I'm also helping on our exhibit development team for our reopening in November for our new partnership and NASA Ames Visitor Center. So pretty exciting. Thanks. Excited to be here.
Good morning, everybody. I'm Lisa Hoover, also from Chabot Space and Science Center. I work in astronomy programs, scouting, and outdoor education. I'm also a reuse crafter and a home gardener. Welcome.
So we'll kick things off, and we wanted to start by getting to know you a little bit and some of your background. So one of the things, if you just entered the room, if you could just put your grade levels that you work with alongside your name on your Zoom screen, that would be great. If you want to drop in your school or organization that you're with, that would just help us see who's in the room. And we've got, just to get to know you a little bit and some of your background, we've got a little survey that we'd love to take with you, to have you take with us together. So I'm going to turn it over to Haley and Christian to run through a couple questions with you.
Yeah, so it's just a quick little survey, and we're actually going to use the chat to do it. So you will answer our questions as how I'm typing in right now. And our first question to try to get to know you and kind of your experience with composting is, have you cared for a worm bin before? You can give us a yes or no, or any other fun details.
Yeah, as well as do you have a garden, or do you have plants at school or at home or at work that you take care of?
And then our third question is a little more fun, a little exciting, and it's on a scale of worm. Which worm are you feeling? Which worm do you, feel today? Which one are you resonating with out of these different worms that we have? So we've got your wormhole, your space worm, your can of worms, your sea worm. So which worm are you resonating with today?
And again, those questions are, have you cared for a worm bin before? Just a quick yes or no. Do you have plants, a garden at home or school that you take care of? And then how are you feeling this morning on a scale of worm?
Always good to ask yourself that in the mornings, every day. All right, lots of no's on the caring for a worm bin before. So lots of new faces to the worm bin world. Welcome.
Cool.
We've got a worm dance out there. We've got a garden worm. Ooh, 2 garden worms. Ooh, we've had some worm bins in the classroom and some desires to start some worm bins at home, which is also awesome. Really cool. We'll talk about the benefits of that as well.
A couple of bookworms and gummy worms, like starting my morning with a hug. Feeling good today. Sun's out.
All right, we've got a great diversity of who we're resonating with this morning. That's awesome.
Yeah, so hopefully today in the workshop, we'll kind of, those of you who've done a worm bin before, you can learn about the benefits of it. And those who haven't, you might get inspired to make one. So yeah, feel free to keep on typing in if you have a worm, but I'm gonna hand it back over to Eric to get us into some earth science.
Great. So just to frame our workshop, we talked about planet Earth being one system, one place that's very special to us, all life as we know it. So let's kind of zoom out a little bit and put us in the context of our neighbors. So this is a picture of some planets in the inner solar system. We call these the terrestrial-like worlds. They're actually the smaller worlds in our solar system, along with the sun. This is obviously not to scale. And so just wanted to just run through and have you do a quick observation of this image and think about what it makes you think of. So maybe looking at the information presented on this slide, maybe you notice something. What do you notice? So drop any ideas in the chat that this image makes you think of. Really anything on the slide that stands out to you. And then you also might wonder something. This might raise some questions for you, right? So what do you wonder about the information provided on this slide? And again, go ahead and drop your ideas in the chat. We'd love to, and anything's fair game. We'll just spend, 30 seconds just noticing and wondering about this image. And if the rest of the team notices anything interesting in chat, and feel free to, we're a small enough group. If you'd like to unmute today, don't be shy to do that. We're glad to hear actual voices if you're comfortable with that.
Yeah, there's some interesting comments in the chat. Some people are noticing swirls. They are wondering about brave people who will try to colonize Mars and what that will mean about temperatures. They're noticing that Mercury is really small and wondering about the connection between its size and the temperature. And conversely, Venus looking very toasty.
Wow, that's an interesting one. So, and keep dropping stuff in the chat. So that's the one that really got me. So I just want to call that one out, this toasty idea. When we look at those temperatures, it seems a little strange, right? Because Mercury's closer to the sun, and yet it's cooler by a little bit than Venus, right? Somebody had mentioned that Earth is in the right parameters. I think, Rachel, you mentioned that Earth is in the right parameters for life as we know it, which is great, having to do with distance in part. But it turns out that distance from the sun is not the only reason that the planet has a temperature that it has. There's something really, really important that we
Some
call—
comments, Eric, about water and clouds and atmosphere and wondering about that impact. So
great observation. You kind of read my mind, because a planet's temperature is impacted not only by its distance from the sun, but by the type of atmosphere that it has and how much of that atmosphere it has. And there's a phenomenon we call the greenhouse effect. And the idea is that as the sunlight comes in to a planetary body, if it doesn't have an atmosphere, it basically kind of gets into the planet and then it just bounces back into space. But if it has an atmosphere of the right type, some of that energy gets absorbed by that blanket of atmosphere in something we call the greenhouse effect. And so the amount of atmosphere is really important, but also the type of atmosphere is really, really critical. So life on Earth, by the way, would not exist without this greenhouse effect. We need it, but there's some issues with it that we want to dig deep into and unpack during our workshop. So if we look at Earth's atmosphere in particular, if you look at that small pie chart kind of in the middle, the one that's got the big blue slice and the relatively large green slice, you can see that our atmosphere is made of mostly nitrogen and oxygen, with a little bit of trace gases, most of that being a gas called argon. Well, it turns out those three gases make up over 99% of our atmosphere, but they are non-greenhouse gases. They do not retain any of that infrared heat that gets kind of bounced off the Earth and absorbed by the atmosphere. So those gases that our atmosphere is mainly made of don't do this. But there's a small subset of gases, which is that other pie chart with the big orange chunk representing carbon dioxide. That's the part of our atmosphere that are greenhouse gases. Those are responsible for warming our planet by 50 degrees. But they represent a really, really small slice or fraction of our atmosphere. So really, really small piece of the atmosphere responsible for 50 degrees of warming. So that kind of sets the stage for our workshop today, because here's some of those greenhouse gases depicted in percentages. Carbon dioxide is a huge part of the greenhouse effect. And these are what humans are doing to the atmosphere to add more of these gases. So while the Earth is made up of a really small amount, we're increasing that amount every day. And we're also increasing another gas called methane. Those are the two I want us to focus on right now. So due to human emissions, these gases, these greenhouse gases, are growing in the atmosphere. And these are the molecular kind of structures or shapes of these molecules in the atmosphere. And I'm just going to play a short video in just a minute. But before we do that, I wanted to just show you the sources of methane in the atmosphere. And if I can draw your attention to this pie chart connecting to our workshop today, landfills are a big part of where methane is coming from. And methane is a much more powerful greenhouse gas than carbon dioxide. So because of landfills and waste disposal, we're getting a lot of emissions of a very powerful greenhouse gas. And so it's growing in the atmosphere. So our workshop is really about that. It's about looking at this methane molecule and thinking about how we can reduce that in the atmosphere through changing how we deal with our waste stream. So that's our frame.
And Eric, I know that often at this point in the workshop, as people start to see your beautiful slides and the information you're sharing, we will make this available correct to everybody afterwards. So feel free to take all the notes you want, but we will be sharing the slides and the other resources. They have put together a beautiful resource page, lots of information. So feel like you can just really remain engaged and chat, and we will be following up with all the resources for you. Thanks.
Yep. Thanks, Teresa, for that reminder. Three principal things: the slide deck, there's a resource page we'll be sharing, as well as the video recording will be accessible via the CRS website. So I'm going to go back, but I'm not going to play this video. There's a link within the slide deck to a short visualization of methane in the atmosphere, but we've talked a little bit about the importance of methane, so I think we'll move forward through this. Oh my gosh, team, what is this? What's happening?
What is this?
There's a wormhole.
Feel that?
This is completely unexpected.
Do you feel that sensation? Is anyone feeling that?
No.
I'm
Haley,
not feeling anything, I'm just seeing it.
what's going on? Yeah, I'm seeing something. There's a worm going through a tunnel. But Haley, what are you feeling?
I'm going through the tunnel. That's me.
That's you?
Yeah, I'm moving through that tunnel right now. Does nobody feel this? Am I going through a wormhole?
Oh my gosh. Well,
Really?
Where have you ended up? Where did it take you?
I think I'm going to Mars, guys.
Oh my gosh.
Oh my goodness.
You.
I apologize to the participants in the workshop. We did not anticipate this happening at all.
I mean, I didn't anticipate going to Mars today, but here we are.
Well, I see the worm tracks that you've left on the surface. So you're obviously there. What's this?
Oh, is that a fellow worm?
Oh, I hate to tell you this, Haley, are you still Haley, by the way?
No, I think the wormhole did something weird to me, guys.
Oh my
I think I've
goodness.
transformed into a worm, and I think my name is no longer Haley, but it's Cadet Wormhole.
Oh my gosh. I'm so sorry. Well, this is again unexpected. Well, by the way, Cadet Wormhole, that's a picture of what we thought might have been evidence for life on Mars, a worm perhaps, but it turns out it's just a geologic deposit. It was not evidence for any life on Mars. It was just a geologic, non-living sort of deposit thing that resulted as part of Mars's processes. So you are the first worm to actually arrive on Mars.
Wow, the first worm to ever arrive on Mars?
Congratulations. That's amazing.
Wow, I didn't know I was so cool. I didn't know I could make it out here.
I think we got to take advantage of this moment, team. Cadet Wormhole's there on Mars. We've lost Haley, I'm sorry, but we've got Cadet Wormhole on Mars. Maybe we can talk a little bit about the difference between Earth and Mars and this idea of a planetary system kind of being a closed loop. Cadet oh my gosh, Cadet Wormhole, you really have transformed. Tell us a little bit about this situation.
Yeah, I mean, wow. I've just been through the journey of a lifetime, and here I am on Mars. And it's got me thinking a lot about composting. And I'm up here on this planet, and it's not Earth, but it's very similar. It's like a closed loop system. These are systems where you have a finite set of resources. And up here in Mars, there's honestly not that many, but I'll try to find some. And in these closed loop systems, whatever I do here on Mars, now being the first worm ever, that's going to have an impact. If I do anything here, if I create methane gas or carbon dioxide, that's going to affect the rest of Mars in the system because there are feedback loops that exist. The atmosphere keeps everything in, nothing goes out. It just cycles through. And Earth is also a closed loop system where the same processes are happening, except there's a lot of people. And up here, I'm all alone. It's actually kind of sad. I wish I had some friends with me here on Mars, but
we're still here for you, even if it's at a distance. We're still here for you, Cadet Wormhole.
Thank you. I appreciate it. But Earth, just like Mars, is a closed loop system, has an atmosphere, keeps everything in, everything cycles through. So the impacts and the actions that you take on Earth affect the rest of the planet, no matter where you are. And even astronauts on the ISS, which we have pictured here, they have to worry about the closed loop system. It's a much smaller closed loop system. They live up there for months at a time, and they have very finite resources that they have to cycle through and make sure that they're using them efficiently. So since I'm up here on Mars, I got to figure out how I'm going to find some resources and what I'm going to do with them. And I was thinking maybe that everybody could help me out. We've got a little Jamboard action. I made it while I was in the black hole because time is an infinite loop when you're in there, guys. You don't even know. So we're gonna do this Jamboard that was just posted in the chat. And in the Jamboard, I'm gonna ask you to help me brainstorm what are the benefits of composting? Particularly composting with a little wiggly worm like myself, or general composting. And the Jamboard's gonna look like this. It's a little Venn diagram, and you can post the benefits of composting on Earth, where you all are, or on Mars, where I am, because we are considering sending people to Mars someday soon. So we have to start thinking about what those benefits might be, and of course, how they're similar in the middle. So Eric is kind of showing us how to put a sticky note on Jamboard if any of you are not familiar with it. You grab a sticky note, you type in your text, and then you place it. And we're going to give you about 3 minutes or less to post a sticky note, or 2, or 3, or however many you want to.
These are great ideas, kind of that wormhole. I didn't realize such a small worm had so much knowledge about this. Is amazing how important you are. I didn't anticipate this, the power of the worm.
I mean, I may look small, but I am mighty. I am a composting worm. I do a lot of good things. All right, so we're getting some sticky notes on our Jamboard. Let's see what we've got. We can compost in both places. Yep, I agree. I think it'll be possible to compost on Mars someday when we get some people and infrastructure up there. It'll help make good soil for either. Nutrients. Good benefits about composting on Earth are things like feeding the soil, breaking up the clay soil. Yes, that's a really big benefit of composting. Worms make tunnels, which helps bring oxygen to the plants and soils and ecosystems. Exactly. I love tunneling through dirt and bringing oxygen to my plant friends.
These are great ideas.
Decrease the amount of materials going into the trash. Yes, we love reducing waste in our landfills.
Look at that wonderful image too of what's possible when we have healthy soil.
Ooh, love it. I love images. Uh-oh. Everything disappeared. I guess we're done with our Jamboard.
Somebody might have erased everything. If you could try a Command Z on your keyboards, we might get it back.
We can go back to the PowerPoint.
There it is.
Oh, there it is.
All right, so spend another 30 seconds with final thoughts, and this Jamboard will be open to you to contribute. There's some additional pages that we won't get into right now, but feel free to add to this during our conversation. So we'll head back to the main presentation.
Thanks, y'all. It helps a little worm like me all the way on Mars to know what the benefits of composting are. I think I'm going to try to start a compost bin while I'm up here, but I'm just one single worm, and usually composting is better when we all do it together. But some of the benefits that you've already mentioned, on top of that, are benefits to our climate. And that's kind of our point today, is that a lot of the benefits of composting, especially vermicomposting, turn around and end up helping our planet the most. One of the biggest benefits of doing composting is that it actually reduces the amount of food waste that actually ends up in our landfills. One thing I learned from our tour at StopWaste back in 2019 was that a huge amount of waste in our landfills is compost. And it's an unnecessary amount, and a lot of that compost could be put in other places. What happens when compost ends up in the landfill is that all of that food breaks down, and as it breaks down, it releases methane gas, which, as Eric told us earlier, is a really big, powerful greenhouse gas. So the more food we can divert from our landfills and turn into composting systems, the better we can handle and reduce the methane gas that we're producing and adding to our atmosphere, and the better we are reducing the effects of climate change related to that greenhouse gas. So reducing waste in our landfills is extremely important. Another important piece of composting is if you do choose to do it locally or at home, that food is actually traveling less distance in order to get to its composting system versus getting picked up by a truck and taken to the landfill. That also helps reduce our transportation emissions of carbon dioxide gas when we burn fossil fuels in our trucks and cars. It also helps create great nutrient-rich soil. One of the biggest parts and roles that I have as a wiggly worm is that I eat the food scraps in the compost. And as I do that, I actually poop out really nutrient-rich soil. So worm poop is a really great soil booster that can help create healthier plants. And the more healthy plants that we have, the better they help farm out carbon from our atmosphere. They can absorb it through their leaves, but they also can put it into the root system, which Angelina is going to talk to us about more later in our presentation. So more healthy plants, better biodiversity is eventually going to help our planet sequester carbon, reduce methane emissions, reduce carbon emissions. Plus, composting is super fun. You can play in dirt, you can wiggle around in it if you're a worm like me, and it can help you gain a better appreciation of nature, our resources, the cycles and the systems that exist on our planet. And in general, having better gratitude and joy about our planet can make you a lot happier. So there's benefits for you too. And so because of all those benefits, I'm definitely going to try to get started on a composting bin up here on Mars, but the soil is a little dry. I'm not sure what to do about that.
You know, Cadet Wormhole, we have an expert on the team. Lisa Hoover is an expert in soils and is, I believe, available. Lisa, are you available to tell us a little bit about soils?
Sure am. I can't wait.
Ooh, perfect.
Good morning once again, everybody. So it looks like some of you have already started some gardens at home or at school, and some of you are expanding, or some of you want to get started. Yay. So let's talk about soil. Soil is classified in 3 different types, and let's go back to a couple of key points that Cadet Wormhole was telling us about in terms of carbon emissions and why gardening it helps improve the soil and how it helps improve the atmosphere. You know, if you think about it, as we get the scoop on dirt here, gardening can help fight climate change. Transportation alone is responsible for just around 8% of carbon emissions. So by growing in your backyard or at your school, we can help fight that. Also think about eating what's in season. Think about if you're eating watermelon in December, where's it coming from? Is it being flown across the world? That's another thing we can do. The other thing you can do is take some of your compost and regrow it. Grow your groceries. Start saving your seeds. Let some of your plants actually bolt and collect those seeds so that you're creating a sustainable loop in your own environment at home. Those are ways you can help. Now, let's get back to the dirty business at hand, soils. So soils come in 3 basic types: clay, kind of sandy, and the good stuff, loam. Now, that's what we want, but what do you think the typical soil is like here on the West Coast? Let's see some answers in the chat. Yeah, we've got some clay, we've got some sand there in Alameda. A lovely day for a trip to the beach, by the way. And we sure would love some loam. I would too. And so worm compost can help us with that. So to test your soil, I have 3 different activities for you today, and you'll be able to download the worksheets to reproduce with your classrooms. I'm going to turn off my background here just to make it easier to see what I'm doing here. 1 second. Voila. All right, so we're going to do a little soil exploration here. We're going to classify a dirt sample. So great, take the kids outdoor, let them collect a dirt sample, get a simple jar, make workstations for students of 4 or 5, have them sift out all of their rocks and what have you. I didn't, in any organic material. Maybe we'll get lucky, maybe we'll find a worm. You're gonna fill your container halfway full with the dirt sample.
And Lisa, they can, if you did bring your extra materials, we had mentioned if you had some soil in the jar, maybe a little bit of water, feel free to follow along with Lisa as she creates this glass jar soil test.
All right, so I've got my dirt, I've got my water. I don't know if you can hear it, but it's like, look, 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 look. All right, gonna give it a good stir here. Ooh, that's juicy. Close it up nice and tight. We're gonna add like a teaspoon of dish soap. It's just out of reach, so I'm not gonna do that at this time. And you wanna have the kids shake it for about 3 minutes to get all of those chunks incorporated. Woohoo! We're gonna pretend that 3 minutes passed, and maybe we'll take a little look at this later. But as the jar begins to settle, you're gonna begin to see it layered. And you're gonna see the heavier components at the bottom, where some of your sandy components are. You're gonna see more of your silt and clay in the middle. And then at the top, some of the lighter and the clay components there. Then,
And Lisa, there was a question about what the soap would do.
what the soap would do?
You mentioned adding dish soap.
Yeah, it kind of helps with the separation of the components there. So I know it's hard to see. I'm going to get as close as I can here, given the lighting. But I actually have gradients here. So the next step would be with a dry erase marker to draw a line between the segments. Now this is a worksheet that you'll be able to download and pass out to the students, where they can actually draw on their digital mason jar and fill in what they're seeing at the different levels. And I can see clearly about 3 levels in this jar here that have separated. Yeah, it helps with the separation there. Then, maybe for some of your older students, we can profile it even further. You might just want to do it visually. What does it look like? Does it look more sandy? Does it look like more clay, etc.? Does it look like more silt? Then, from your sample, you're going to come up with the percentages of each type. So on the model here, it says, oh, we have about 35% sand. On the triangle there, we're going to go to the sand component, the 35%, and make a mark there, or put your finger there. Perfect. Then you're going to figure out the percentage of silt and do the same thing. And then lastly with the clay, and then you'll triangulate, sounds like going to space, triangulate the position of the 3 points, and where they meet is your classification. So in the case of my sample, it turns out that I have clay soil, just like the model here. Now, you can also, without this experiment, just do simple observation. Collect different types of dirt and examine it, get a spray bottle for the young ones, let them get it wet, examine them, etc. So let's go on to the next slide.
Can I ask a quick question? Is it always that distribution with the sand on the lowest level, the silt in the middle, and the clay on the top? it seems counterintuitive that the clay would be the highest level. You would think that's dense and it would sink down below the silt.
Sand is heavy, so rock and sand, the heavier gritty stuff are always gonna fall to the bottom. And mud is a little, like clay and mud, or a little lighter. Let me see what that question was, sorry.
Well,
Putting up my chat.
yeah, there's how you're getting that question. These are just some additional things you can think about doing with your soil.
Yeah.
Squeezing it.
So next is examining the soil itself. Great to go outside and get dirty. Collect the dirt when it's, maybe after a fresh rain, when it's moist, give it a little squeeze. How dense is it? I can't squeeze my soil. It's Rock of Gibraltar out there. Might hurt myself unless I watered it down. It's really compact. Water it. Water the ground. Does the water actually run off or sink in? If it's running off, it's not being absorbed, and that's an indicator that your soil needs some help. And finally, investigate your worm count. Worms are an indicator of how healthy your soil is. So on our next worksheet, you can pick up collect a 12 by 12 sample, and then plop it on the table and let the kids actually do a count. And depending on the number, and there's a chart in the worksheet, you'll be able to determine how healthy your soil is. If there's no worms, you have sad soil. You want to make it happy. It needs some worms. All right there. So a worm count is an excellent way to examine the health of your soil. Pyramid. Great. You're also going to find other things in your soil samples in terms of critters and whatnot. And wait, do I see something? Something wiggling there? I think we have some soil.
Yeah, just 1 second. Let me see if we can bring that up. Hold on 1 second. So it turns out, Lisa, I actually have a worm compost bin at home. And so I was able to gather some of that for our soil exploration together. So I'm going to see if
That you look like you're in Mars, Eric.
I
don't know.
It does
Are you
look
up here on Mars with me?
Yeah.
Like we said, Cadet Wormhole, I think this would be an interesting thing to do on Mars, wouldn't it?
It would be.
So anybody notice, drop into the chat what you're noticing. It's a little, what do you see in the worm compost here? And I'm using a pair of chopsticks, but I'm actually not gonna eat these things right now. What do you notice? What do you see? Let's see if I can, let me tell what that might be. Hard to see a little bit, but let's see. Well, let's get to the stars of our show. Anybody's Cadet Worm? Holy moly, there goes our microscope. Just fell. So this is a neat little digital microscope that you can get, and it plugs right into your USB port. And it's a little dark, but let's see if we can bring in. There we go. Can you see our little red wigglers? The stars of our show.
Oh, I see a worm. It's like seeing myself on the big screen.
I thought you might get excited by this, Cadet Wormhole.
I finally made it big.
So these red wigglers are amazing decomposers. They can eat up to half their body weight every day, which doesn't, I mean, they're small, but they're powerful. As Cadet Wormhole shared with us, she has the ability to compost a tremendous amount of green waste and convert it into this beautiful soil, which Lisa was sharing is so important to have, not only have enough soil, but have it of the right proportions when you're trying to grow specific things like vegetables and fruits. We want to have a really nutrient-rich kind of a soil. And then there's also other critters in here. So maybe you can take a moment in the chat and see if, using that chart that's on the screen, what other critters could you identify in our compost? And let's see, it's a little hard to see, but
We
there's,
get a full screen of those worms.
oh, thank you. Yes, we could do that.
Eric, I have a fun fact. So the things that we can observe are what we call macroorganisms in healthy soil and compost. But did you know that in a tablespoon of healthy soil or compost, there are over a billion microorganisms that you can't even see? Over a billion.
A billion microorganisms in this little soil. Can you imagine?
Let me tell you, when I try to compost up here on Mars, it's pretty hard to do all by myself. I definitely need some friends to help me out. I love a good mite. Mites are pretty fun to hang out with. Sow bugs, they're nice too. Ooh, who's that?
Ooh, there's some fun ones in there. Fun
Oh,
microorganisms.
they're all on top of each other. Social distance.
Yeah, we're not practicing mask wearing here, are we?
Eric, with the type of microscope that we have a lot of elementary teachers in the meeting today, with the type of classroom microscope that's typical in an elementary classroom, would students be able to see this? Or is your digital microscope a little bit more powerful than a basic elementary classroom microscope?
You know, honestly, a magnifying glass is a great starting point, even before the microscope.
Ooh, even better.
You get a lot of great views just with a magnifying glass, a hand lens. And then, yeah, just a standard simple microscope. Doesn't have to be, even have to be a compound microscope, works great to get a little bit closer view. I like to put the worms on a Petri dish or something, then you can stick that onto the stage of your microscope. And then the digital microscope, sure, it does give you a little bit more definition, a little bit closer look, but it's really not necessary. And we're hopeful that by the fall, you'll be back in person with your students. And this kind of exploration, just testimonial to it, having done it so many times with students, they love worms. They just love to see them dig in. It's a chance to kind of encourage them to be gentle. You know, we don't want to leave the worms out of their soil because they need to stay moist. It's probably best not to handle them with our hands as much because we dry them out. But it's a great chance for them to see something wiggling and squirming and do some identifications and classifications. You know, you can, as Lisa mentioned, one of the things you can do is you can start sorting your compost by what's in it. Material, you know, food scraps. This is a piece of asparagus, for example. I've got a carrot in here. So they can start to kind of push things around. There are living things, there are non-living things, and even start to classify things by type of life. You know, the little red mites, those little red guys that you're seeing squirm on the screen here are actually only about 1 millimeter in length. So they're really, really small, but they're super important in the decomposition process. So I'm going to turn it back over to Lisa and maybe Haley to kind of bring us home on our soil exploration.
Yep, we'll bring it back up. So you can see some of those little critters that you may have noticed. And yeah, really fun stuff. I love hanging out with my friends, doing some compost stuff. Lisa, want to let us know a little bit more about how to test soil?
Absolutely. The other thing you can do is test the pH of your soil. And that's a clear indicator of what kind of soil that you have and what it might need in terms of nourishment. So in addition to the moisture test and the profile of type, we can test the chemistry of our soil. Just like our stomach, you know, needs sometimes the right balance of acid and base. Same thing is true of our soils and our plants in order to absorb nutrients. And so what kind of soil do you think we have here on the West Coast? We've established that we have mostly kind of dry clay and sandy soil, but do you think it's typically acid or alkaline? Another word for base. Or I don't know.
And Rachel's sharing, as she thinks acidic. A lot of soils are typically acidic.
So it turns out that here on the West, most of our soil is alkaline. It's actually fairly basic. And so a great way to test it is with a universal pH indicator. But if you don't have that, classic pH red cabbage juice will do the trick. This will be another worksheet that you can download for your students. Chop up one red cabbage and boil it in distilled water, and that will make a universal indicator. And if you don't have distilled water, that's fine. It will work with tap or bottled water as well. Yeah, and the soil is different in different places in the world. Here it's really dry and alkaline, and it has to do with the mineral composition in our kind of rocks that break down and become part of our soil. So let's see, I have a little white dish here. I have a little red cabbage juice. Gonna pour it in there. And it's as simple as that. And then drop in your soil sample. Have the kids, I know that's hard to see, mix it around a little bit and wait for the color reaction. And then I'm gonna magically make it appear behind me here. Come on, computer, a little faster, please. Voila, I'm directionally challenged. So there it is. On the pH scale, you can clearly see that it's really alkaline. So one of the ways I can bring it down, make it more acid, and the reason I want it more acid is the ideal pH for garden is between a 6 to 8 range. And you can see the kind of common household items. It's fun to discuss with the students on the range there. So to bring it down, raw compost worm castings is about 8. So I can really bring down my soil pH to a more medium level. Now, some plants actually prefer even more acidic soil, such as our fruits and our berries, especially blueberries. They like it really acidic. And so there's additional things you can do there. But typically, we will find mostly alkaline soil here on the West Coast. And pH chemistry, with household products and foods is really fun. You could even do a chromatography test by, pulverizing different plants and, getting the pH of vegetables. The options are endless. So I encourage you to garden, to grow something. The name of image on number 1, what do you mean?
A battery. I think it's a battery. The zero.
Oh, yes, a battery. Battery acid is very acidic.
I think 0 is
This will be a
battery.
worksheet. What was that?
I think it might be a stomach.
Oh, number
Oh,
1.
stomach acid.
Yeah.
Oh, number 1. Gotcha. I was thinking number 0. Yeah, stomach acid is, yeah. So I encourage you to garden. Really helps with worms to oxygenate the soil by moving and creating air pockets where the plants can actually absorb the nutrients and water and air. So Angelina is going to bring it home with some more information.
Yes, so thanks Lisa, Eric, and Cadet Wormhole for breaking down how compost and worms and soil help solve global climate change. And to help us digest it all like a worm digests a good apple core, let's pull it all together. So when we feed our soil compost, we're creating healthy soil. That healthy soil creates healthy plants. Healthy plants have healthy root systems, and that root growth is key for sequestering or farming greenhouse gases like carbon dioxide out of the atmosphere that contributes to the warming of the planet. This is what we call carbon farming. Like this visual shows, carbon farming practices draw carbon dioxide from the atmosphere and stores it, sinks it deep into the soil, a process called carbon sequestration. And these techniques focus on growing healthy plants and building up soil microbes, those microorganisms, and root growth. And my friends at Occidental Arts and Ecology, they shared with me that healthy native plants can grow roots 25 feet deep. And you know what that means? That means that those plants can absorb and store carbon 25 feet deep into that soil. And those healthy plants, roots naturally exude carbon dioxide as carbohydrates, which feed and nourish those soil microorganisms. It is a system. It's wild. And when those microorganisms and plants die, they break down and build up the carbon stored in the soil. So feed your soil worm compost, and that compost feeds those plants and microorganisms. But in addition, another way that worms and worm compost solve global climate change is when you use worm compost as an alternative to synthetic fertilizers, you are solving global climate change. Because when you use synthetic fertilizers or herbicides, they harm, if not kill, those amazing microorganisms that play an important part in storing carbon in the soil. And if you remember, Eric shared that nitrous oxide is a super duper powerful greenhouse gas. Synthetic nitrogen fertilizers can cause nitrous oxide greenhouse gas emissions, a greenhouse gas that traps 300 more times than carbon dioxide. So you're doing a lot when you are using worm compost, and worms and their soil ecosystems with micro and macroorganisms are truly action heroes. Can we take the challenge and help them join them to be action heroes? I don't know. What do you think, Christian? Do you think we can?
Hello, everyone. It's Wiggle E Worm here.
Oh, wiggly worm. What?
Hey, I would like to thank you for composting your food scraps and yard trimmings to feed us.
Hey, Wiggly.
Wiggly, wow, so great to see you.
We'll do our best to eat, play, and poop our way to help reduce global warming by global worming. Hey.
Great.
The world we all need will be created together. Cadet Wormhole, next slide, please.
Every superhero gotta have their theme music, right? This is the Eco Hero Anthem. Eco Hero symbols up. Eco, let go.
Welcome, students, to the headquarters of the 4Rs Action League. Reduce, reuse, recycle, and rot is what we will explore today. We invite you all to join the journey with us and to take steps to protect planet Earth, waste less, and join our league. In this first video, first, we will explore what we care about. Second, we will reflect on the power of one and the power of working together. And lastly, we will create our very own Action League identity to connect with our bigger mission, which is to waste less. My name is Cristian Aguilar, and I am a member of this awesome league. What makes this league special is all the amazing people that are a part of it. People like you and me that come together to learn. Our first step is to introduce ourselves and begin to explore some of the things we care about. My adventure began by creating my 4Rs Action League identity. As a member of the Action League, I am known as Christian Cantaloupe because I love to eat fruits and vegetables. They help me to stay healthy so I can continue to learn and grow. As I think about my life experience, the good and the bad, I am able to further explore where I come from and what I stand for, to then reflect on my connection to the planet. My love for sharing stories with my community and family has brought me to this very moment, to explore and protect where I live and the people I care about. Our community, planet Earth. The 4Rs Action League believes in you and in our collective power of one. We all have the power as human beings to create change. Let's come together and use that power to learn what we can do about waste. Just one act of kindness or planting one tree at a time makes a big difference. When we take action and waste less, our communities thrive, and together we are powerful. As we come together to work as one and contribute to a culture that centers taking care of where we live, we ask you to think about what actions you can take to waste less.
So yeah, that was a welcome video that we've been working and building out our Action League throughout the years, and we have some more examples as well. If you can go to the next slide, please. That wormhole. And yeah, so I've actually had the pretty unique opportunity to really take the time to reflect and align myself to the 4Rs Action League, and I'll be sharing a piece of that experience. And when I take action to create positive change, I'm known as Christian Cantaloupe. Next slide, please. So here's my origin story. So my climate action hero origin story. So I come from a lineage of educators, and over 10 years ago, my role as Christian Cantaloupe, a food rescuer, was created at an Oakland public school, Lazier Elementary. It's our local neighborhood school. And one of the amazing students by the name of Eileen invited me to support students to properly sort and reduce waste in the cafeteria. It was actually a plan she learned at StopWaste, and this was way before I became involved with StopWaste. But really, it was this amazing experience within the cafeteria and like just the culture around food, that we were able to bring dignity in sharing surplus food for the school and the community to have access to. And we got to protect and support the people in our community, and really this idea to develop and grow into responsible and autonomous learners. Next slide, please. And really for me, it was important to stay with my personal identity, just to stay myself. But let me tell you about one of my many superpowers, and I think I get it from my mama. But this idea of Post-its, I put Post-it notes all over the place. And this specific one was, kind of bringing back the idea of the importance of food and where it comes from and how we relate to it. And yeah, by just staying myself, I've also had the opportunity, because don't get me wrong, I love to dress up and play in a character. So right, I get to dress up as Wiggly Worm, and just the amount of love and joy that comes from going to assemblies is just truly awesome to be able to share that experience with students. Next slide, please. I got one more cool thing to share. What? Another wormhole? All right then. At this time, we're asking everyone to join and go through the wormhole together. And you could do this by please renaming yourself. If you're inspired, you could make your own nickname, your own Action League name, and you could change it on Zoom, as well as sharing something that you care about. So this is your official initiation. So I'll go ahead and drop mine in the chat, and you could as well.
This is crazy. Christiana, I've never experienced anything like this. Cadet Wormhole, is this what happened to you?
I mean, do you feel a sensation that you're changing and becoming a better person to help the earth for better?
I do, but I don't know where I'm going or what's happening to me.
You must be in the wormhole. You are in the wormhole.
I'm going too.
Oh no, Angelina's in the wormhole.
Ah!
Oh no,
Help
the whole
me.
crew.
What's happening to me?
Lisa,
Seeds all
you're
over
kind of
me.
there too?
I don't know.
All right, everybody's changing in the wormhole. We'll see what everybody comes out as in the other side. And those of you in the audience, if you want to go through the wormhole with us, think about your superhero, who you're going to be. Join us on the other side.
It feels really good to be on this side.
I see. Oh, Angelina, who are you? You are no longer Angelina.
I've evolved. I'm not only Angelina, but through the wormhole, I have become food rescue mama. And this amazing thing happened where I was like, man, I really want worms to be part of my family. And check it out.
Oh my gosh. Are those yours?
Yes, these are my new wormy friends. And we are like this dynamic duo. Like, I make sure that food waste doesn't go into the landfill to make methane. And these guys and gals, and however they identify, they eat my food scraps and make worm compost. It's amazing.
I love it. Will you adopt me?
Anytime. You and our billions of microorganisms family.
I do need some friends up here on Mars. Lisa, what's happened to you, Lisa?
I think I've gone full range gardening. I've got seeds everywhere. I think I'm now the seedy gardener.
Wow, CD Gardner, what's your superpower?
Oh man, I make things grow.
Oh my gosh, I love growth. It's like a jungle gym for me to wiggle around in. Eric, you look really lost in that wormhole.
Oh my goodness.
Wow, that was incredible. I'm glad I'm not alone in this adventure. I went through the wormhole and my personality like bisected, and I was joined by this primate.
Oh no.
Far out.
Oh my gosh. Who have you become? Are you space monkeys?
Yes, we're space monkeys, and what is that? Oh, you're the commander. No, Cadet Wormhole's in charge here. You got to chill out, man.
Hey, I don't mind giving up power to Space Monkey. I'm cool with
All
it.
right.
I'm just a little worm over here.
It's a little feisty sometimes and wants to take over, but our superpowers is we care about all living things. We care about not just primates like ourselves, but all living things. And we want to support the team in caring for the earth, caring for our planet. And so we really feel like that's our superpowers, looking into the future and developing a positive future by working together and solving climate change through global warming, all the things that we've been talking about.
Wow, that's a great superpower. And Christian, what's going on over there with you? Did you make it to the wormhole?
Yeah, I made it through the wormhole, but this time I just want to reintroduce myself. Hello, everyone. My name is Redford, and when I learn and take action to reduce the impacts of global warming, I transform into Super Reducer. And actually, my cape just fell off. My fit's in the works. So this is just part of my super suit. The rest is being created. But right, it's just this idea of enjoying, right, and aligning with the experience that we want students to also have. So yeah, as Super Reducer, I'm a member of the Action League along with my amazing friends and many, many others. We have many examples of people joining the Action League, and we will love to hear from you. Let us know how you too are a climate action hero by creating an identity, a super name, a catchphrase, superpowers, of course, and really your origin story of what you are all about. And these are a lot of resources we have to pass along as well. Cadet Wormhole, next slide, please. So without further ado, I would like to introduce a very special guest, more members of the Action League. And I would like you to meet Rock Girl and her amazing friends. So lights, camera, and action.
Somewhere in a school, very much like your own.
Looks like everyone is composting their food scraps from lunch. Rat-tastic! Oh no! That student seems to be heading for the garbage bin with that apple. Snap out of it! Are you okay, fellow student? You were about to throw that food scrap into the garbage bin.
Oh my head. It's like I wasn't even thinking about what bin my apple goes into. In fact, I don't even remember walking over here.
Because I was making you waste it.
Oh no, it's the trashster!
Yes, you were under my control, following my every command. And I would have gotten you to waste your apple if it wasn't for you, Rock Girl.
Maybe so, but I never work alone. That's right, Chester. Quickly, fellow student. Compost that apple by putting it into the green bin.
You got it.
No! Because of you, I'm decomposing! I'm decomposing!
Wow, I'm transforming into a student action hero!
Rock-tastic! As you see, fellow student, everyone has the power to reduce waste by composting their food scraps. Let's go put this compost in our school garden.
Hey. So yeah, I'm just always amazed by just the creativity of young people. So let's please give a round of applause and share some love in the chat for all the amazing students sharing the importance of learning, growing, and taking collective action to reduce global warming. We've been building out our Action League experience throughout the years, and honestly just really excited to continue and adapt and evolve this culture of caring, this community. So yeah, hopefully y'all be able to let us know how it goes. Next slide, please. And
All
with that,
right. So thank you, Super Reducer. So now that we are all action heroes, it's time to take action. Maybe you are now No Waste Nancy and want to take action at home, or your students to take action at home and make a worm bin. Or maybe you're Caring Kate, want your class to build a worm bin in your class, or like me, Food Rescue Mama, and with my son, Earth Ninja, we want to find a community garden to join and start a worm bin system. Or maybe you're doing one of these action projects and want to do all those things, like having your class teach how to make a worm bin at your community garden. The possibilities are endless, just like worms' appetites for your food scraps. So whatever your idea is to take action, we have a planning guide to help you develop your action plan. It's a model that some people here actually helped us co-create. It's a regional model that we're calling the 6 A's framework. We have a guide sheet for you in our resource guide that you can refer to later today. Next slide, please. So the 6 A's to taking action is a way to develop a personal or collective plan to be a climate action hero at home, at school, or in your community. And the first A, and really, we're trying to demonstrate today how to go about all these A's. So the first A is assess and prep. What world do you envision and aspire to? What actions could you do to get toward that vision? And what questions do you have?
The next A is audit. The questions to help you audit are, what do you have and what do you need to have to make your action plan happen? What can you do to collect more information or data to help you take action?
And the third A of our plan is analyze and plan. What does the information around you tell you? Maybe you've done a waste audit or you've gathered some information. What research or materials do you need to further analyze and plan? And then from there, what steps can you take?
Our next A is action. Take action by making observations and capture your project from beginning to end. Document everything. You're on mute.
Thank you. Yeah, I was on mute. And the next A is aggregate, evaluate, reflect, and celebrate. What does our audit tell us?
And the last A that we actually created during this workshop is adapt, because we've had to adapt virtually, but it's also good to adapt. What would you do next time? And really have that reflection of what could we do better? What are the lessons learned from our successes and failures? Because we know failures are sometimes the best teachers. So do you think we're ready to take action? Space Monkey out there?
I feel like we've got all the tools we need. We've talked about the connection between composting and global climate change, something a small worm, the impact a small worm and taking your food waste can have, with 40% of our food waste going to landfill. If we divert that, we're doing an incredible job helping to solve global warming through global warming. We've presented some ideas about soil explorations, how you might even compost on Mars, which is crazy to think about. And then we've created this opportunity to create action heroes. Sort of what's our personal passion inside of us, each of us, that drives us to teach our future generations about sustainability. And I didn't expect to go through a wormhole this morning, but to be transformed into a space monkey and to care about the planet and to see a super reducer, a food rescue mama, a CD gardener, and a cadet wormhole all at the same time joining me in this transformation. And then the rest of the participants willing to come along. Are you all willing to come along with us on this crazy sustainable future journey? That's awesome. We're so glad that you're here. So I think with that, we're ready to take the next steps. And we'd love to hear from you about what those next steps might look like as educators of our future generations. How might you use, or how are you already using some of these ideas in your teaching? What resonates with you? Thinking back to those worms at the very beginning of our workshop, you resonated somehow with one of those crazy worms. Maybe it was a bookworm, maybe it was a worm in a hole, maybe it was, something else. But tell us a little bit about your engagement and anything that you heard about today and or you're already doing. We'd love to hear.
I'll share. I know I'm not a teacher here, but I don't actually have a compost bin in my own house. And after doing this, I'm actually really inspired to try to make one. because there's no reason I can't do that. And I have a lot of composting, and I just put it in the compost bin. So I'm inspired to make a compost bin at home and start in my own place.
Hey, Cadet Wormhole, we we actually taped our webinar at StopWaste. So it's an hour-long video that essentially takes you from starting a worm bin to harvesting a worm bin to applying your worm compost, and it also does some troubleshooting for sure. So I will make sure it's in the resource guide.
Okay, perfect. I'll check it out.
Also, that's a reminder, Angelina and Christian and Ariel's joining us from StopWaste on the call as well today. There's an opportunity, if you're an Alameda County resident in particular, you can get a free batch of worms to start your own worm composting system. You just have to coordinate through StopWaste. If that's of interest, just reach out to anybody, any of the presenters today. Our contact information will be included in the resource document that we send you. But these worms are free. And there's enough to get you started.
I can go real quick. I normally do some fun activities with my science method students where I bring in like earthworms and we kind of just play with them like as a way to like do some hands-on science. But I think this is a great way for me to take it that next step. And I talk a little bit about environmental principles and concepts like later on in the semester, but I feel like trying to integrate it into every lesson is super helpful. So this is a great way for me to get more of the environmental impact, within that lesson as well. So it should be fun.
There's a lot of great material in the StopWaste Healthy Soil document, which includes the background for the activities on the soils that we did today as well.
I really love the idea of exploring soils in your own environment, going outside and students collecting their own samples and really thinking about it. And then everywhere you go, you can start to think about, oh, what's in that soil? And both the living and the non-living components of the soil are both really, really important. And that starts to get you into ecosystems and other things. I mean, just opens all sorts of questions. But just tying it to where I live, like my backyard, and then I can go collect that sample and then I can do something with it and find out something, see something that I never saw before, like making something that's invisible visible with that, shaking it in the jar. That's just so cool. I just think that's a really magical thing to do with kids and important.
Great. Well, I definitely appreciate it. And if you have more thoughts, definitely jump in. But just a little bit of background on this workshop. So like I mentioned, I worked for years together with Lisa and Haley at the Chabot Space and Science Center. And along the way, Angelina and I partnered when she was working at East Bay Conservation Corps. And we had this fantasy project of, we got to do something about worms in space. Somehow we got to make the connection between Earth and maybe going to the moon or going to Mars and, these closed loop systems. So this is sort of the fruition of, I don't know what, Angelina, 15 or 20 years of thinking about a project. And I guess this is one of the upsides of COVID. We had an opportunity to get crazy on Zoom and create an experience for you. But yeah, I've just personally had a blast really working with the five of you on this project. It's, just some of the things, I mean, you're probably noticing some of the things after doing Zooms for the last year that we tried out, like Lisa changing her background, us kind of creating a storyline within the workshop, that we're going through a wormhole. So we wanted to do role plays, characters, not just tell you about how characters, but show you. I believe in workshops that show, don't just tell. And I think the rest of the team, feel free to jump in, but I really have appreciated this sort of role play fantasy kind of, just jumping in and not being shy. And I think as educators, if we can remember that this is a huge topic, right? Global climate change is big and it's on the minds of our youth. And it's hard, but there's things we can do, and infusing humor and sort of envisioning positive next steps to me are all really, really important when we teach our youth. So I just appreciate, can't share enough with you. This has been my favorite project this year to work on with the five of you. So thanks so much for jumping in and getting silly with us today.
Yeah, and I'd just like to chime in. Yes, this has been a dream project. and some folks on this call, we're working collaboratively with. And I do feel like global warming does bring our community closer, for sure. And one of the things that an educator said is, if you're going to ask students to protect the earth, you have to first have them love it. And I think that's what worms and worm composting in the classroom has really done for myself as an educator. We see those faces light up when they interact with a living organism, and they're just a little closer to understanding this wonder of the earth with us. And the other thing through the years too is, a lot of us talk about curbside composting. And even though Alameda County is, generally pretty good at that, some students don't have access to curbside recycling still. And we feel like, as we talk about equity more and more, especially in the pandemic, it's been so cool always that worm composting is that access to that experience, because you can have a worm bin in your classroom, you can have a worm bin in your apartment, or on your porch if you can't handle it in your apartment. So just really appreciate this space, and thank you, everybody.
Yeah, it's been great. A lot of people are, because we've all been stuck at home for so long, have been pandemic gardening and wanting to make it, a success. And so a chance to tie that in to people, I love working with. Grateful to be involved. Thanks, Space Monkey.
Yeah, worm composting is just, Haley, that's really great that you want to start one, because I grew up like Lisa, doing gardening, and Lisa and I live in the same neighborhood, and it's incredible, Lisa, what you've done with your garden, especially in these last 4 or 5 years. You just created this oasis in her backyard of edible food, and really is growing her food, growing her meals, and that's so like hyper local, being carbon neutral, and just such a great way to go, and teaching students about that. So it's healthy food, food equity, lowering carbon footprint, building soil, solving climate change. I mean, there's so many upsides of this. And then for me, like, I've been worm composting and for the last 21 years. So I think it might be the same colony of worms, they keep multiplying, obviously, but that I've had for 20 plus years. And the soil is incredible. I mean, what we explored, with the video microscope, the one year my dad, this is probably like 10 years ago when he had a garden, he got a truckload, a pickup truck, and he dumped it onto his raised bed garden. And I swear, not a joke, the cucumbers were jumping rows. Like, they were just so vibrant, so rich. The soil was just so amazing. So that what you get out of garbage, what we think of as garbage, is just, it's incredible. The soil, I can't recommend it more. And if you're haven't done gardening, try it out. And it doesn't smell. People get kind of put off sometimes by worms, but when you do it right, it's aerobic. It's aerobic decomposition. So you just don't get a smell. It smells like rich, nutrient, great soil. I wouldn't say eating it would be a good strategy, but it's okay to smell it.
Thank you, everybody. I'm going to jump in here for just a moment to say I'm going to stop recording.